Hello everyone and welcome back. So in today's video we're going to try to replicate a similar effect of this procedural animation by Dave Bombs. He's a quite known motion designer. I'm not a motion designer, but I'm going to try with VEX to do something similar. So here's my attempt. As you can see, it's not exactly the same, but it will give us a challenge or two to recreate this. So let's get into it. So let's start by dropping a geo. And we're going to divide the box into 5 sections. So for that, I'm going to drop a box and a line. I'm going to go pretty fast in here, just to not waste too much time with this. I'm going to place it in the center. So home. And I'm going to set 6 points. So we'll have 6 points. Now I'm going to Voronoi fracture this. And we'll get this result, which is not aligned. So what we need to do is to convert the segments into individual lines with the convert line, and then we can just extract centroid. We have done this plenty of times in the channel, so we just do this, and now we have 5 sections. All right, let's create a null. So we don't want to work with this full geometry. What we need to do is to pack it. So, and since we have the name attribute, as you can see, we can pack using that name attribute. So if we just check name attribute, now we will have 5 points. Let me see if I can draw wire over packed geometry so we can see the wireframe. So now we have 5 points and we can use the pack transform to manipulate and animate everything. So this is going to be a bit intense, but let's try to keep it manageable. So I'm going to create a new wrangle, set up a color in here, and connect it. So first of all, we're going to work with time since we're going to animate. So the first thing we're going to define is the variable time. And it's a good idea to define it as a channel, as a parameter, so we can later change the timing and whatnot. So instead of referring directly to at time or a $t, we can just refer it as a parameter. So let's name it time. And let's just set this to be at time. Now, one of the first things we're going to do, and now if we check that variable, it will give us time. One of the first things we need to do is to get the pack transform, since we have that. So matrix transform will be equal to get packed transform, and the arguments are incoming geometry and the prim num. So now the first thing we're going to animate will be the geometry going around in circles. So for that, we're going to create an angle variable in here, and let's just say it will be time times pi, and I found a value of 0.166 will make a perfect loop. And if we set this to be 116 frames, this should loop perfectly. So let's create first of all the matrix that we're going to manipulate, which will be just initialization of ident. And then we can just use the rotate function. So we can say rotate, and we want to rotate the matrix that we created. The amount will be the angle, and the axis for now it will be along y. And let's check that. So nothing happens because we need to set the pack transform, of course. So at the end of the wrangle, this will be our last line. We're going to set pack transform, incoming geometry, I at prim num, and we will multiply the initial transform by the new matrix, or the initial matrix by the new one. And now this should rotate perfectly. It will be a bit slow, but is the velocity I need. In this case, I think I'm going to increase time by a bit, so 1 to 5. Let's see if that loops perfectly. and it does. So there might be a way with math to make this look perfectly by fitting the timeline to 360, but I don't want to worry too much about that. So I just did this by eye. So that's our first animation. Now we want to do, let me see, the exploded view, which is when the geometry separates. And if we check the exploded view compound and we allow editing of contents, we will have something in here that will be really similar to what we're going to do. So I just use this as reference. So the first step would be to get this bounding box center. So let's move this rotate down and we will compute the bounding box center. So vector center, it will be the get bounding box center. That's our center. Now we need a center for each piece. So for that, I'm going to create a vector named piece center, and it will, oops, and it will be get point bounding box center, and we will feed as a group each point number. So in this case, I to A, I at PT num, and that should work, as you can see. And now, in order to create the exploded view, we will use instead of rotate, we will use translate. So let's have a look at that. So I'm gonna create in here, before the rotate, I'm gonna create a translate, and we're going to translate the matrix, and I'm gonna make this a vector, so cast it as a vector, and it will be, let's say, we first of all we need some animation. So let's say time, and we're going to multiply it by the center minus piece center. Let's have a look at that. So as you can see, it is growing. We don't want that. We can do scene time and make it absolute, so it goes between 0 and 1. Let's see how that looks. So in this case, I think we just need to make it to negate it. And as you can see, it's going between the two states, between 0 and 1. Previously, it was going the other way around. So, but this is not what we want. We want it to stay closed, then open, and stay closed for a while, then open, and then stay open for a while and repeat. So for that, we're going to need to create a ramp, and I'm going to call it anim A. So after the matrix, I'm going in here, or after this, I mean, we can do float anim A. It will be a ch ramp, and it will be anim A. Just the name, and I'm gonna multiply time by 0.35 was a value that worked well for me. So let's set this up. So if we replace this, let's see how that looks. Well, we need to create the ramp first of all, and it won't look like much, and it will just repeat it once. So we need actually to work on the ramp. So as I told you, we want, let's set this to B-spline at 0. We want to stay at 0 between 0 and 0.15. Then we will raise it, so open, and it will be on a value 0.35. We can even create in here another one at 0.5 to make it flat at the top, and make another one at 0.65, I believe. Yeah, 0.65. And then just drag this one to 0.85. Let's see how that looks. So in this case, it's going the other way around because we need to actually revert it. So yeah, we need to revert it. So instead of anime, we will do negative. So let me see. This is 0, this is 0, 0. It will open. Let me see if I change anything in here. This one is at 0. And I think we also need to repeat it. So for that, I'm going to just use frag. And thanks Alam for that. He helped me on this one to make it repeat. And let's see. So let's see this again. It's opening too fast. I think I changed the interpolation to monotone cubic, so it's a bit more linear. So now it's repeating perfectly, and as you can see, it's holding at the peaks. This one is repeating with the frag, so we get this constant loop. So yeah, that's our exploded view. Now we want to do the rotation, so a new rotation. And for that, we're going to create a new animation, so a new animation variable. So in this case, after the animation A, we're going to create the animation B. So float anim B will be equal to chramp, and we'll name it anim B, and it will have the input as local time, a variable that we will create. So let me see how I do this. So let's create a float local time, and it will again cycle. So we will use frag, and we will use again time times 0.35. So that's fine. And now we want to animate, so we need to close in here. And we want to animate each section at a time, so with a small delay. And for that, the solution I found was to subtract from these float I at ptnum. And let's look at that if we now do a rotation. So in this case, we will rotate it again in here, and it will be, in this case, I'm gonna rotate it by pi divided by 2 times anim b, and it will be along the y, yes, anim b. And let's see how that looks. So it's not rotating much, is it? So, and oh, we need to create the ramp, of course. And now it's just increasing the rotation. So we need to play with the ramp. And the ramp will be really simple. So at 0.35, and it will be again monotone cubic. And this one will be at 0.65. So 0.65. And this is monotone cubic, that's correct. And now let's have a look at that. And as you can see, when it's expanding, it will do a full rotation. But we want to do one at a time, so right now it's not working because we need to make this a fraction of the current values. So right now is just too big, the value, I believe. So we need to divide it. So this is not a perfect solution, but the solution I found was to divide this by a big number. So we get something like this. But now I don't like that starts at the bottom. I want it to start at the top. So for that, I'm going to create a new variable in here called int invert pt, and it will be equal to I at number of points minus 1 minus ptnum. And now if we do, instead of pt num we use invert pt, we will get it from the top. So that's half of it done, or most of it done. Now we just need to rotate it sideways. So now we need to toggle the position or the rotation angle. So we want it to go up and then go along the x-axis. So for that we need to do a rotation in steps. So in this case we can just use, let me see, we have the angle in here, we can do it in here. So I'm gonna create a new matrix. So for that I'm gonna use vector 4 and I'm gonna create a quaternion, and it will be just a quaternion, and we will rotate by the angle that we will create and along the x-axis. So that's fine. And now the angle variable, float ang, it will be just 90 degrees, so pi divided by 2. And we need to create a new we need to create in here a toggle to toggle between the two states, so it is in steps. But for now, let's just create in here a matrix tree called rot, and it will be just q convert the quads, because we need what? Because we need to work with matrices. And now if we multiply also this rot, let's see how that looks. And now it just does the rotation and nothing else. We need to toggle between the state. So for that, I'm going in here and create a toggle times by 2. And for the toggle, we will create it after the env, so in here before the translate, because we will need it for something else. So let's create an int toggle, and it will be equal to time divided by 3.0 was the value I found worked well, and we will floor it, and we will also modulo by 2, so it alternates. And we also want to convert it to an int, and we close the bracket in here. And let's see how that works. So as you can see, we have them stacked vertically, and now it should rotate to the sides. But in this case, I also want, so let me see. Let's get rid of some of the rotations. So this NMB we can get rid of. And we can also get rid of the first one, so this one. Let's see if that is changing properly. And it does. As you can see, it's working. We just need to change the axis of the sum of the rotations so they follow the new orientation. So this is working, and now if we enable the first one, which is just rotating around, let's see. And as you can see now, the axis is different. We need to change it. Should be different, I mean. So for that, we can just do after the toggle. Let's create in here a vector axis select or cell, and it will be equal to select, just like an if. And we will use as a condition the toggle, and we will switch between along the z-axis and the y. So set 0, 1, 0. And now, if we rotate the angle, and instead of using y, we will use axis select. So there might be other ways to do this. This is just a crude way I've found that works. If it works, let's see. And it does. So let me see. But now is, as you can see, is rotating the other way around. So we need also a sign, and we can take advantage of the toggle for that. So after creating this, we can create in here a sign, so to multiply by -1 or 1. So float sign, it will be equal to toggle, which alternates between 0 and 1, but we want to make it between -1 and 1, so multiplying by 2 and subtracting 1. And so float sign toggle. And now we can just multiply the angle by the sign, and it should rotate in the correct direction. Let's see, and it does. Now it's only rotating clockwise, as you can see. Now we just need to add the other rotation, and let's see if we need to make something different. So it's doing some wild things. I don't mind this one. This one in here, it's kind of interesting, but it's just broken. So in the anim B, that's what we enabled. We need to multiply this also by sign. So multiply by sign. And so pi2 anim B sign. Let's see. And there's still something missing in here. So in this case, we first want to rotate this one. So that's the issue, I think. So if we first rotate this one, let's see. Yeah, that's the thing. And yeah, I believe this is mostly done. Now we just need to work on the colors. And as you can see, is repeating, is looping perfectly. But we had to set up some manual values and whatnot. So not a perfect solution, but it's what we have for today. So let's create another angle. And right now we're going to do the colors, and it should be simple enough. So let's do color and give it some color. And we will have a ramp going around the relative point bounding box. So for that, I'm going to create a vector ramp, and it will be a vector of a siege ramp, and it can be color ramp. And for this, we will use relative point bounding box, incoming geometry, V at P, and we just want to use the Y component. So siege ramp, we need to do another bracket. So maybe not. So vector. Oh, and we need one in here. So this should work, right? And now we can create that. So this should create a color ramp. Why not? Or the expert parameter. So vector. Am I doing this properly? So let me check something here. Relative point bounding box 0p ch ramp. So this should create a color ramp, but for some reason it's not creating. So yeah, let's not worry too much about it. So maybe if we do something like this, so let's delete this and create it like this. No. So I just experiment with this ramp to cast it as a color, and if we as a color ramp. So if I enable this, as you can see, it will create this linear ramp. Let's delete this and let's remove the spaces in here to see if that works. And as you can see, it creates a color ramp. It's a bit weird. We don't want spaces in there for some reason. So yeah, a vector ramp. It will be this, and we also want a vector. We want to create the color diffuse, so or you can just assign it to V at CD. It will lerp between, so lerp between a vector color. Let me cast it to see if it works, but I don't think it will work. So color 0, and we want to blend it with ramp, and we want to use the anim A that we haven't saved yet, but we will. So let's go in here. Where is anim A? So yeah, in here. So f at anim A, And now let's create the parameters, and as you can see it didn't create the color, so let's edit parameter interface and change this to color. And now we want to set this, we want to invert this and connect this color in here, or this color in here, to this one, and I'm gonna change this to some blue. Let's see. And somehow is inverted. No, it's correct, sorry. So we should be looking at this. So yeah guys, and if you want a smoother result, you can turn on these fractional frames and it will give you a much smoother result, as you can see. And we can come in here and change the color to something like this. So yeah, that's basically it. Hope you have enjoyed this one. Let me know in the comments what you think. And as always, you can grab the files on my Patreon and go ahead and support the original creator of this. And yeah, guys, that's it. Thank you. See you next time.